Now that we have the domain over which we want to solve our governing equations, let's divide that domain into multiple cells or control volumes. If I go back to the framework of what's inside the black box, I want to remind you that in the meshing step, we are not affecting the mathematical model, we are affecting how that mathematical model is going to be solved. In particular, we're going to mark out the selected points at which we want the solver to calculate velocity, pressure, and temperature. I'll go to Workbench and right-click on Mesh and say Edit. And twiddle my thumbs a bit for the mesher to come up. Once the mesher comes up, you should be able to see, geometry, coordinate systems, and mesh. And I'll highlight Mesh and click on Update to get the default mesh. And I can zoom in here using the right mouse button and drawing a rectangle. And I see it's just created a single cell across the pipe, which is not what I want. So let's put some sizings in. I'll say Mesh Control, Sizings, and I'll put the sizings on edges. So I'll select the Edge Selection filter. I'll select the 4 horizontal edges. So I'll click on this edge first. Then I'll click on the, I'll hold down Control key and click on the other edges. So that's my second edge. I will zoom out using that, and then I will zoom in using the right mouse button. And then I will click that and that. So I should have 4 edges, and I'll come over here, click, and say Apply. So I'm applying the sizing to 4 edges, and I will set the element size to be 0.05, which should give me 300 divisions along the pipe. And make sure your units are set to meters over here, and then that's set to 0.05 meters. And then for the radial edges, I'll set sizing. So I'll zoom out here and zoom in here and click on this radial edge. Then I'll zoom out. So you have to keep manipulating the model because we have a long skinny rectangle. And then hold down the Control key and click on that. And then I will say sizing. So I'll say Insert Sizing. So the scoping is already selected, the 2 edges. So you can, put the sizing in and select the edges, or you can select the edges and put the sizing in. It's the same thing. And I'll say number of divisions is equal to 30. And I can set the behavior to hard. I won't do this. It just means that this is a hard setting, and usually that, that's a good idea for simple geometries. But in this case, it doesn't have much of an effect. So I'll let that go. And I'll say Update. And then if I go to Mesh, I see that I'm getting this irregular mesh. Whereas I really, it's a rectangle, so I should be able to divide it into rectangles. And the way I control that is I'll go under Mesh Control and I'll say Face Meshing. And Face Meshing gives me a regular mesh. And I'll select that face. We have only one face. And say Apply. And I'll say Update. And this might be familiar to you from the conduction tutorial if you've gone through that, or the laminar pipe flow tutorial. And then if I go to the mesh, now it looks rectangular, the cells, if I zoom in. By the way, if your model gets askew, something like that, you can zoom out here and then you can click on Z. And it shows me a 3-dimensional visualization. Our mathematical model is 2D, so ignore the 3D visualization. Okay, that's misleading. So I'll click on Z and I can zoom in or zoom out. Let me zoom in. And I can actually, if I go in here, this looks a little slanted, and that's related to this message we get. So if I go to messages here and see these messages, so the first is an information, the second is a warning that all cell zones maybe set to fluid. And in this case, we have only one zone, and that's a flow domain, so that's okay. And then if I come to this warning and I double click on it to see it, it says something like the specified defeaturing tolerance was found to be bigger than a specified size. And that specified size is over here under sizings. But we don't want it to, use those sizings. That's useful for complex geometries. But for simple geometries, we want to turn it off. So we can do that by selecting adaptive, which is not intuitive at all. Okay, so select adaptive and then say update mesh. And you should see that warning went away, and now you're getting, nice regular rectangles. So, and I can zoom out. So that's my mesh. I have, a number of, I've divided my rectangle into a number of rectangles, rectangular cells. And if I come down here with mesh highlighted and go to mesh statistics, I'll see that I have 9,000 elements, which I should read as 9,000 cells. So I have 9,000 cells, and at each cell, right, it's going to calculate 2 components of velocity and 1 pressure, 1 temperature, so 4 variables. So 4 times 9,000 is 36,000. So essentially, by throwing this mesh at the solver, I'm asking it to calculate 36,000 values, which means it needs to calculate 36,000. It needs to generate 36,000 algebraic equations. That's all there is to meshing. So I'll say File, Save Project.